Howdy everybody in YouTube land. What we have in front of us today is a Powerbook 180c. Now I've already covered this in previous videos, so there was no footage on this machine of it being restored and glued and caps and all of that stuff because that wasn't important and that's not the topic of this video. However, I decided to start doing a video on this one now because this one has a problem. So if I plug the power into it down here, so the power's plugged in. Notice we're completely dead. We have no power. So we finally get one here, which it's rare. I don't think I've ever seen a Powerbook 100 series yet where it just refused to turn on without the battery installed. Most of the time they won't turn on if the battery's installed, but this one refused to turn on at all. So we got to figure out what is going on in here because there's a reason why this thing's not turning on. So let's figure it out. Oh, there's one thing that stands out to me right away. I did dry check all the diodes and transistors on the bottom side of it, and I'm not seeing anything. However, with my probe on the battery terminal, we can follow the filter. We're through the filter, one side of the fuse, because there's a 5 amp fuse right here. We're good. Other side of the fuse. Open! Yeah, see? So we have a 5 amp fuse that's went open circuit. So something really serious went wrong that opened that fuse. My thought process is there was a battery in here at one point that was internally shorted. Maybe the power adapter had enough kick into it, which blew this fuse. So with that fuse blown, we're not going to get anything. So that's important. We got to fix that. All right, so here's what we're going to do. We're going to do a very sketchy maneuver. So I've got my meter probe on the 5 volts output. So this design goes all the way back to the Macintosh Portable. We have a single transistor that supplies the 5.2 volts to the rest of the system. Same type of design. So right now we've got no voltage. So if I plug that in, it kind of bleeds up a little bit, and if we press the power button, we get nothing. Now, what I'm going to do is I'm going to try to do this single-handedly. This is the dangerous operation. So I'm going to jump this fuse with the pair of tweezers. See if we get any smoke. And we don't. However, our voltage returns. So, there we go. We need to find another one of those. I'm not sure where we're going to get that, but that's what we need to do. Unfortunately, I do not have a fuse. So what we're going to do is pull one off of a parts board. This is exactly why I keep parts boards around. Now this one's Varta bombed. There'll be a video on that out eventually. Not much I can do with this board. It's garbage, but good place to steal fuses from, so I'm going to steal one. Alright, here we go. Zoom out here. Plug our power in. Ooh. That's not good. We're running at not so great of a voltage. Yeah, reset. Oh wow, that's not good at all, actually. Oof. Yeah, that's supposed to be 5 volts. That can't be good for these chips. No, 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 no. In fact, that chip is warm. Oh, man. So that's what blew this fuse, probably, is some issue going on with that. With the regulation circuit. Interesting. Well, let me check this transistor and make sure it's not leaky, because that would do it. After chasing my tail round and around and around, the Powerbook 140 schematics are available, and the power supply section, besides the part designators, is basically the same. And what I'm finding is this 1077 is just going full tilt. And our 1.2 volt voltage reference that this thing uses is fine. So I'm starting to suspect we got something going on in there. I don't know for sure. This is a very, very, very difficult circuit to troubleshoot because there's a lot of weirdness to it. That's, I don't know. So I grabbed this Powerbook 140 parts board out of my junk bin. I'm going to, because the CPU card was bad on this one, and I don't know what happened to it. It's gone. So all I have is just this board. So what I'm going to do is play Ring Around the Parts Cannon. I'm going to move this 1077 over to here and see if the behaviors change. All right, this is going to be very hard to get on camera, but I swapped that 1077 around. I got the other one over there. Didn't solve my problem. So instead of throwing the parts cannon at it, I started looking at things a little bit. So one thing I've noticed right away is on this particular board. This is the bad one. This is the 140 board. So if I measure across the 5-volt MOSFET here, between here, and actually, I don't know if I want to be able to do this single-handedly. Let me shove, because here's the thing. That jack goes straight over here. So if I measure here, maybe. Yeah, see. Now, if I measure this middle pin, which is our 5-volt output, look at that. There's a 0.1 volt drop across that junction. So, of course, my 7 volts is going to try to shove its way through there. That doesn't make sense. Because if I come over to this one and do the same thing, I should get continuity here. And I do. But here, look, no short. So, is it this transistor? What is it? Well, let me pull that transistor out and see. Because if this is leaky, that'll be our problem, right? Because if that transistor is bad, that would certainly cause everything we're seeing. Alright, so what's going to be hard to do again is to hold the camera at the same time. Yeah, that's... Let me get off this camera for a minute. I want to get that pulled. Alright, with that transistor pulled, let's check this transistor. I have a feeling it's bad, and that's what our problem's been the whole time. But let's find out. We'll grab you. I'm trying to do, again, single-handedly here. I need a better setup in this room, but my tripod just will not fit in here. Ugh. Okay, that ain't gonna work. Alright, let me check the board instead. That'll be easier to do, because now I don't have... Alright. Yeah, same problem. So it's not the transistor. Okay. What could it be? Well, I tell you there's one way we can find out. This is probably not that advisable, but what we can actually do to figure this out is I can solder a couple wires in here across this junction, and I can apply a couple volts through here, and wherever the short is gonna get hot. You feel around, you'll find the short because it'll get hot. Once we have located that, then we're gonna know. So let's do that. But that would certainly explain why the fuse blew. That would certainly explain it. Or when I replaced the fuse and jumped it, whatever was failing finally failed entirely. Because remember, when we first jumped this fuse, we actually had the proper 5.2 volts, and then it just disappeared. So I think it was a... anyways, we'll find out. Let me try that. All right. So we're at set 1.9 volts. Now, how we've got this wired up is we're following the channel direction. What I mean by that is, we know the input side on the drain is higher than that on the source. I think it's the source, or it might be the other way around. The center pin is your 5-volt out. Your outer pin is your 7.5-volt in. So that's the direction of current flow. So that's why I have my positive voltage in here and my negative, or ground, right there. Just to make sure we don't damage any circuitry. So what we're going to do is slowly turn this guy up until we start to avalanche. Looks like we're not avalanching yet. Oh, we're getting closer. We're getting closer. Oh, yeah, she's getting warm now. Let's see. Let's have a feel around here. Oh, fuck. Yeah, wow, wow. Right here. Q46. Whoa. Ow. Yeah, let me turn that down. Q46 is getting red hot. So what does that correspond to on the 140? Q43. So what is that in the schematic? Let's take a look. So Q43 in the schematic is, let's see, Q3, Q7, Q5, I don't know. There's just Q39, I don't know. You can't read that one over there. Q43, here it is. Right here. This guy right here is Q41 is not getting hot. It's in parallel. But Q43 is getting hot. So that is our bat charger coming through here. And it's shorted. Well, there's our little 5 amp fuse. Well, so that doesn't make sense. Yeah, there's our battery voltage input, which makes sense. Goes down to here. But that means this guy is tied to our 5-volt supply somewhere. So if this transistor is turned on, that would be why it's getting hot. That means this signal here is tied to 5-volt. It's tied to this guy. No, it's tied to here. That means BAT CHGR and plus 5-volt SH are shorted together. That doesn't make sense. We shouldn't have that, so we need to investigate that. So, alright, so I pulled this transistor out, and our short is still there. The transistor tests fine out of circuit. Yeah, it was getting hot. Makes sense because there's a circuit path to ground or around a loop. There shouldn't be. Here's what I did find out though. Our 5-volt output, which is right here. If I connect my probe to that. So that's our 5-volt out. If I probe the battery, our 5 volts is going straight to the battery pins. No. I wonder, did I fuck this up? Did I create a bridge here that shouldn't be here? Oh god, let me remove this fuse. You know what? I'll give me a minute. You know what? It was my fault. So, let me show you what happened. This whole thing was caused by me. Now, if I meter it now, between here and here, no more short. It's gone. However, if you look right here, there's a little via. So this fuse, when I put this fuse in here, a little bit of a solder blob made it between the fuse and the via. I'm hoping it didn't blow stuff up on this board, because that is a real possibility. Alright, let's try this again. Alright, fuse is back in. This time away from the via that's right there. Sheesh. Alright, let's try this again. Oh my god. I cannot believe I did that. You know what? I'm only human. I make mistakes. So the problem was a blown fuse. Who knows why it was blown? Could be from a shorted battery, like I said earlier. But then I created the problem with it not going into regulation. Because I was literally dumping battery voltage into the regulator and it was trying to compensate. So that would explain why it didn't want to work. Alright, well, I guess now it's time to find out if I've damaged anything on this board. 'Cause who knows? Alright, let's see how badly I screwed this thing up. Plug you in. Blue SCSI's in there. Power on. It'll take a minute for it to initialize the blue SCSI. Oh, I saw an activity light. I don't know if it's going to access anything, or will it? Hold on. At least it posted. I didn't lose the CPU. Reset button. Do we get anything? Oh, yeah. Nice. Oh, my God. It's working. Oh, my Lord. So all it was a fuse, and I created all the rest of the problems. But you know what? It's fine. Alright. Good enough. I'm going to start putting this thing back together. Alright. Try this again. This time, with a little less fuck-ups. Alright, here we go. Hey! We got a chime. Do we have... There we go. I forgot these 180Cs do that. All right. This is great. It's working. So, moral of the story is, if it doesn't turn on, check your fuses. Replace your fuse. That's a little 5 amp fuse. Replace your fuse if it's open, and do not solder to the adjacent via. It will tend to work better. Anywho, we're gonna continue on with this. Yeah, everything seems to be working fine. I'm copying over everything off of my blue SCSI onto the internal blue SCSI that's inside this thing, so that's pretty much all I wanted to cover. If you've got a Powerbook 100 series that just does not turn on for any reason whatsoever, completely brain dead, and you don't see any physical damage on the board, like fried diodes or anything like that, check the fuse. That's it. So this is a quick little interlude video, and then me going around in circles. Anyways. So if you enjoyed this video, don't forget to hit the like and subscribe and all that fun stuff. Please feel free to leave a comment if you have one. Until next time, guys, thank you for watching.